Using a unique variable for every item in your program can only take you so far. What if we have an example where we need to have 100 different integer values representing different things, or we have a dozen different floats that represent different things? Well, fortunately, the C++ language, as with all other languages, you have the ability to declare a variable and give it a dimension, and you only have to declare the variable one time, but it can hold as many numbers as you want. The only restriction is that everything within this thing called an array, it has to be the same type. So in this video, we will look at one-dimensional arrays. We'll look at how to define them, and we'll do some operations with them. I'm going to begin with this skeleton program, and part one, as you can see here, we're just going to define some one-dimensional arrays, and we're going to initialize them to some values. When you are declaring an array, we just use a special syntax in order to do that. I'm going to put 3 arrays here, and let's examine the differences between them and how they are initialized. So I'll paste the code in. And here we have 3 arrays. Now let's look at the syntax to begin with. You still have to come up with a variable following the rules, and then if you want to make it an array, we just add on the square brackets with some number in between. So we use the square bracket notation. That's one thing new, and the number that you put here indicates how many values that you want to store in this array. So in this declaration, this array will contain ordinary integers. It will contain exactly 10 of them. And the second array, I have a float, and its name, the array name, is values, and it will contain 20 floating point numbers. And the last one is just an unsigned integer. So you can declare any type that you want and then use the identifier, square brackets, and how many elements that you have in the array. I've also shown in this example how you can initialize an array. We use the curly bracket notation for that. And in this case, we're just initializing this array of 10 integers to the numbers 1 through 10. So we start with the left curly brace, and then you separate the numbers that you want to put into the array with commas, closing curly brace, and then a semicolon. So this allows us to initialize the array when we declare it. In the case where you would like to initialize the array to all zeros, you can use this shortcut. And this only works for the number 0. So in this second example, the float array values, there are 20 of them, and by setting them equal to 0, then every element in the array will be set to 0. So we don't have to go through and type 20 zeros here. And in the last example, we have an unsigned integer. It's called even. It has 10 elements or 10 numbers, and it only has 3 initialized. So you're allowed to do this as well. This will initialize the first 3 elements of the array, but it doesn't initialize the remainder. Now, in some instances, you will want to initialize your array using this notation, and in a lot of instances, you'll just want to set everything to 0. Now, let's print out some of these array elements and examine them a little bit further. So let's print out some of the information. So I'm writing out to the screen just the array contents, and here's some other variables that we'll use later on. And I'm going to print out numbers sub 0, 1, and 9. So one thing that's very important when you're accessing the elements of these arrays is that the index begins with 0 and the last index is 1 less than the dimension of the array. So in the case of numbers, we have 10 elements, but the indices go from 0 for 1 up to 9. Index 9 has the number 10 in it. So when we print these out, then you'll see the actual values coming out of the array numbers. And I've added a system pause here so we don't proceed any further with the program. So let's compile and run the program. Let's bring in the output. So here are the values. Okay, so if you look at index number 0 of numbers, then it contains the number 1. Okay, so the first index starts with 0. Number sub 1, well, that's the second element of the array. So we print out the number 2 there because the index for that one is 1. Now, as we continue, all the way across, if we printed out index number 9, then that's the last element of the array. So one important thing to remember is the indexes begin with 0 and they stop with 1 less than the dimension. Now let's print out some numbers from the even array, which is only partially initialized. So let's put the code here, and let's compile and run the program again. Now let's bring in the output. Okay, so in this case we're printing out some values from even. So the index number 0, that's the first number, so that was 2, you can see here. And then we don't have anything specifically stored for indexes greater than 0, 1, and 2. So index 3, 4, 5, 6, 7, 8, 9, those are not initialized within our curly braces here. When we print those out, then we get 0 for index 6, we get 0 for index 9. Now, I need to warn you that that might not always be the case. When you're initializing your array, if you do not fill in all the elements, then it's possible that you will not have zeros filled in automatically. So please be aware of that. All right, now let's proceed with some additional examples. The next example I'm going to do will involve some more arrays. So I'm going to paste in some declarations for these arrays. So you can see they're all going to be type integer, and I've named them array 1, array 2, the sum array, product array, and difference array. So we're going to initialize array 1 and array 2, and then we're going to do some operations on it. We're going to subtract and multiply and divide some of these arrays. The notation I've used here, we still have the square bracket, and I've set all these arrays to be 0. So they're all set to 0 when I've declared them here. But where did this come from? What about size? Well, if you haven't run across this already, then you can define this thing, call size or any other variable that you want as a constant. So in this case, I have a constant unsigned integer, and the identifier for that is uppercase size, and I've set it to the value 100. Then in any location, anywhere in my program that I want to use size, then the compiler is going to replace that with the number 100. So that makes it easy if I want to change the size of the array in the future. I would only need to change this number to 10 or 200 or whatever I want. Then I wouldn't need to change the code anywhere else. So that's the advantage of using this constant, this thing that's declared up here. All right, so whenever you see size, then you can just think 100. So these arrays each contain 100 regular integers. Now, we're going to use a random number generator to initialize array 1 and array 2. So let's go ahead and add the code to do that. So we'll paste in the code, and I'm going to use a for loop. So let's examine this very carefully. So with the for loop, I'm just using this integer value I, which I've declared up here as an unsigned integer. So that's just my loop control variable. So I begins with 0, and I continues as long as it's less than size, and then we just have the increment operator for I over here. So I is going to go 0 up to 99. Notice I is less than, not less than or equal to here. Inside the loop, we're going to index through every element of array 1 and array 2. So the value for I starts with 0 and it goes up to 99. So that covers the entire size of the arrays. Okay, I should do array 1 and array 2. So we're going to loop through every element of that array. The for loop is going to do that. The way that we generate a random number is to call the rand function. So the rand function, notice the empty parentheses here. The rand function is going to return a number, which is an integer value, between 0 and roughly 32,000 and something. So if I just didn't have this extra stuff over here, then these random numbers would be 0 up to 30,000 and something. But I want to limit the range of these numbers to be 0 to 99, so I'm multiplying, or that is, I'm really using the modulus operator and the number 100 to limit the size of these random numbers. So what this is really doing is it's going to store the values 0 up to 99 into the array. So rand modulus 100 will give me a number 0 through 99. So those are the numbers that will be stored into the array. So let's just add a little comment here to indicate that. So now we have the comment that indicates what this line of code is doing. So it'll do the same thing here for array 1, and we can put the comment here as well because it does the same thing. So we'll have numbers stored into array 1 and array 2 that are just numbers, integers 0 through 99. Well, we'd like to see those output, but we can't see them until we print them. So the next step here is to print out the elements of the two arrays to the screen. Okay, now I've got the comment this does 10 per line, but let's just print them out 1 per line first. So let's paste the code here that will allow us to print out these values. So it's very similar. Now we are still printing, or we still need to access all the elements of the array. So we have the same for loop. I goes from 0 to 99, I++, and we'll output the values. I've got a set width of 3. The numbers are 2 digits, so that'll be more important than the next step that I do. But we'll just index through every element of the array from 0 up to 99. We'll print it out, and then we have the end line over here. All right, so before that, let's print out the array that we're actually printing here. So this will be the output from array 1. So I'm going to get another line of code and put it up there so we can keep track with what we're printing. So we'll print out array 1, and then we'll print out all the elements of the array, and then I've got the system pause right here. So then we'll come back, we'll do array 2 in just a minute. So let's compile and run the program. Now we can look at the output. Okay, so here we have array 1, and let's adjust this a little bit so we can see everything. So we have the loop that's printing out everything, and you see the loop here. So we print out array 1, and then we go through and index 0 through 99 and print out each number, 1 number per line. So there are 100 random numbers from 0 to 99. Now, I'd like to modify this a little bit so that I don't have a long string of numbers going down the screen. I want to print out 1 per line. So I'm going to add a little extra code here. I'm going to take away this end line, and I'm not going to print an end line every single time I print a number. So I'm going to put an if statement here that will only print out the end line when I get 10 numbers written out to the screen. So it looks like this. So I'll paste it in, and look at what this is doing. Our counter I starts with 0. So if we have 0 here the very first time, then we are going to have 0 plus 1 is 1. So this number is going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 100 because I'm adding 1 each time. Then I'm going to use the modulus operator. So if this number is a multiple of 10, then it will equal 0. That will make this statement true, and if it's true, I'll print out an end line. So this will end up printing 10 numbers per line. Okay, if I want to change this modulus to 5, it would print 5 per line. If I wanted to do 8, it would be 8 per line. 12 would do 12 per line, and so on. So this thing, as long as it's a multiple of whatever the modulus number is here, then this will be equal to 0, it will be true, and we'll print out an end line. So this now will print out 10 numbers per line. It'll be easier to see them on the screen. If we scroll down, I want to see what's in array 2 as well. So let's do the same thing to print out the elements of array 2. That's pretty easy. I can just copy the same if statement that I had here. So I'm just going to copy that, and I'm going to paste it after we print array 2. Paste that in, and instead of printing out array 1, we'll just print out the contents of array 2. Okay, so I just changed 1 to 2. Now let's take out some extra space, and let's move the system pause, cut it from here, and we'll place it down here. All right, so now we can initialize array 1 and array 2, and we can print their contents out to the screen. Okay, so now let's compile and run the program. Take out some more space there. Okay, compile and run the program. Now we have the output, and you can see that when we print array 1, now we do get 10 numbers per line, so now we can see all of the 100 numbers at once. So the random number generator that we used up here, that produced random numbers, and we used the modulus operator to cut it from 0 to 99, and there you can see we have numbers that are two-digit numbers from 0 to 99. Okay, so there's a 0, here's a 97. I'm not sure we got a 99, but that's the limit that we would have. Okay, so same thing for array number 2. So we generated 100 random numbers, and it does have a 99 right there. All right, so we have then, what have we done? Let's take a look at what we've done. We have declared the arrays, array 1 and array 2. We initialized them to 0 to begin with. Then we used this loop, this for loop, along with the random number generator and the modulus to initialize those arrays. So we went through each element of each array and we generated a number, we stored it into the array. Then we just had the 2 for loops that did print out all the numbers to the screen. So we didn't have to use the curly brace notation up here and list 100 numbers, although if we wanted to, we could have, but that begins to be quite a bit tedious after a while. So normally you're going to read data from a file, or you're going to use some random number generator to create the contents of the array. Now let's move on to the second part of this, and let's look at how we can manipulate data that is in those 2 arrays. So part 2. Okay, we're going to do some addition, subtraction, and multiply the elements of array 1 and array 2. And then we'll store those results into these other arrays. So when we add them, we'll have sum. When we multiply them, we'll populate the product array. And when we divide them, we'll put the elements in the difference array. So let's add the code to do that. We'll paste the code here. And we're using that same for loop. So for part 2, we want to add, subtract, and multiply. Let's start by adding. I'm going to save the sum of each element in an array called sum array. So sum array is the same size as the others. It's 100 in this example. And when you're adding an array, you have to add each element individually. So we're going to access the first element of array 1, index 0 to begin with, and the first element of array 2. We'll add those 2 numbers together, and we'll store them into index 0 of array of sum array. Then we'll just keep going until we get to the end of this, which will be index number 99. So we can't just add in a big conglomerate. We can't just add them together. We have to use the indexes each time and add each element one by one. Well, if we can do the addition by adding, then the only thing we really need to do for the other operations is to just add a similar line of code where we do a multiply or we do a divide. So let's just paste the code in for that. I can just, I'm going to paste the code in by using the previous example. Edit. Now let's paste the code in to do that. So now here are the other 2 operations. So the difference array is going to be array 1 minus array 2. So again, element by element, so number by number. And if we want to multiply out the elements of the array and save them in the product array, then we just use a multiply here instead. But again, you have to go through these elements one at a time, and that's why we need the for loop here to do that. Well, once we have produced these arrays, the sum, the difference, and the product, we'd like to see what they look like. What are the contents of those arrays? So let's print out those things. We'll print out the sum array, the difference array, and we'll print out the product array. So we can do something almost identical to what we did up here when we printed out the contents of array 1 and array 2. We just have to use the different names of the arrays. So let's add the code to do that, and let's move the system pause down even further so that our program will progress. So I'm going to cut it from here, and we'll paste it way down here just before part 4. So let's put it down here. Okay, now let's add the code to print out the array sum. So I'll paste that in, and the same for loop shows up, and it will for all of these because we need to go through from index 0 to index 99. You know that by now. And we're just going to print out the sum array this time. The only difference I've made is since we're adding numbers that are 2-digit numbers, then I want to make the width 4. Otherwise, the numbers will be running up against each other. So let's make our field width 4 this time to print out the sum array. Then let's also put the code in to print out the difference array. So that code looks like this. Same loop, We are now printing out the difference array instead of the sum array up here. We have one more to go. We need to print out the product array. So we'll put the code in here to do that. So here's the code. And for loop once again, but this time we are printing out the product array. When I multiply two-digit numbers together, I could get a really big number. So I'm making the width 6 this time so that there's plenty of room to print out these values. So it's pretty easy. We have just done these simple arithmetic operations, add, subtract, multiply, and we've printed out the results. So now let's run the program and see what the answers are. I'll bring over the results. So here's array sum. So when we added the numbers together, then we just get these values, and you can see we have some 3-digit numbers here. And those are all printed out. There's 100 of them, and we print out 10 per line, just as we did when we printed out this array 1 and array 2. Now, when we subtract the arrays, we do get some negative values, not surprising there. So when we subtract array 2 away from array 1, array 1 minus array 2, then these are the values that we get. So we have 100 of those. And when we multiply them, we get some really big numbers, and we have 10 per line again. And this is the result of multiplying two arrays together, and you see the result here in the product array. Now let's go on and do some other operations with these arrays. Let's use a while loop this time, and let's find the maximum and the minimum values in array number 1. This time I'm going to use the while loop, so here is an empty while loop. So instead of using for, I'm going to use while, and I have to initialize the value for I outside the loop, and while I is less than size, then I'll do whatever I need to in here, and at the bottom I'll increment the I loop control variable down here. All right, just to show you a different way to go about it. I still like the for loop best, but this shows you can do it with a while loop. The idea here now is to find the maximum and minimum values. So we need to start out with something for max and min. So I've got an integer declared up above for maximum and one for minimum. And let's take the first element of array 1. And let's initialize max to that value. And let's also initialize min to that value. Now if you looked back, I think that first number is 41, but we can run it and make sure. But this just gives us a starting value for max and min. Now, inside the loop, we're going to look at the next element of the array, and we're going to compare it to max and min. So if the number that we read is larger than max, we will reset max. If the number that we read is less than min, then we will reset min. So we just have to read the element, and then we do our little if statement here. So let's add the code for that. And here are the two if statements that we need. So if array 1, index I, if that one is greater than max, then all we have to do is to set max equal to the new element. So if the second element were 88, then it would be larger than max, and it would reset max here. Okay, we can also reset min. So if the element in the array is less than our current value of min, well, we just replace it. Okay, so the new min will be whatever that index element is out of array 1. We increment the I value, and we continue until we exit the loop. Once we exit the loop, then I've already got the cout statements to tell me the max value and the min value. So let's just run this last example, and you can see that's the end of our program. So we'll see what this result gives us. Now we have the output, and you can see that we get, for the maximum value of array 1, we have 97. The minimum value is 0. All right, well, let's scroll up to array 1, and let's look at what we have. All right, so indeed, the first element of array 1 is 41. The minimum is 0, so we should be able to find a 0. So here's 1, and here's 1. So there's two elements that are minimum at 0. And the maximum was 97. So here's 97 over here. There's also a 96 in there somewhere, but here's a 96, but there's no 99. So for array number 1, that is our maximum value. So this while loop then shows you how you can go through the elements of an array, and you can pick out the max and min values, and then we can print those to the screen. Well, that brings us to the end of this example. So this is the introduction and a review, probably, for how to how to declare and how to initialize and how to operate on one-dimensional arrays. So let's stop here.